So welcome back to mathematics class, and we were talking about statistics. So let us see how far we have covered. So in the last class we were talking about the graphical representation of data, and we had stopped at the frequency polygon, right? We had stopped at the frequency polygon, and in this class we will start off from there itself, and then finally we will look at the measures of central tendency. So let us start off from where we had stopped. So we were talking about the frequency polygon, which was drawn by joining the midpoints of the rectangles, right? And we had asked you why were the area of the polygon equal to the histogram, right? Why is this so, and why are we taking these two extra points where we have zero frequency or we have no data at all? So let us look at the figure closely. If we consider this triangle and this triangle, there are certain similarities, like if we consider this angle and this angle, both of them are equal, right? They are vertically opposite, and this one is the midpoint, right? So you can easily find that this length is equal to this base length. It is very easy to find out. You can directly draw it on a graph and check this out. And this angle 90 degree, which is same as this angle. These two angles, both of them are 90 degree. So you can easily say that these two triangles, this triangle and this triangle, have equal areas, right? And obviously this part is included within the frequency polygon itself. And this is the similar case with these triangles, right? This triangle is similar to this triangle, and this triangle is similar to this triangle, right? So if you consider individual triangles at every stage, you will find out that actually the area of the histogram is equal to the area of the frequency polygon, and the extra portions are added to make the area of the frequency polygon exactly equal to that of the histogram. You can see here we have added the initial point with zero frequency. Why? Because we wanted to add up this part which was being left off the frequency polygon, right? So this is why frequency polygons have same area as that of the histogram. And now you know how to draw the frequency polygon if you can draw the histogram. And obviously frequency polygons are also drawn for continuous data. So let us see an example. So here we are given a set of continuous data, and the corresponding frequencies, or the numbers, or how many numbers are there which occur in the range of the given class intervals, right? We are given the corresponding frequencies and we are given a continuous data. So now you can easily draw a histogram out of it, right? And once you have constructed the histogram so that each rectangle, the areas of each erected rectangle corresponds to the frequencies, after that you can join the midpoints of the class intervals. You can join the midpoints of the class intervals, and finally you get the frequency polygon, or the dotted line shown here, right? And be careful, the histogram is not included in the frequency polygon. We only term the dotted lines as the frequency polygon. We only use the histogram as a help. Now you can also draw the frequency polygon without drawing histograms, because you were just concerned with the midpoints and the values which the histogram reaches. Right here you can see the histogram reaches at a certain height, and you are taking the midpoint of the class interval at that frequency. So frequency polygons can also be drawn independently without drawing histograms. And let us see how. This is because when you are drawing histograms, you are just taking the help of those heights and finding the midpoints. Now, if you are given the midpoints from earlier, if you are given the midpoints and you are also given the corresponding frequencies, you don't need a histogram, right? You can directly join those points and get the frequency polygon. And also one point, between every two midpoints you can see the lines are straight, they are not curved. Between every 2 points you should draw a straight line. Yes, the curve may be a bit steep or not very smooth, but between every 2 points the graph should have a straight line. Now, how to draw frequency polygons without drawing histograms? For this, we require the midpoints and the class intervals used in the data, right? We need the midpoints of the class intervals. So how to get them? And by the way, these midpoints are called as class marks. The midpoints which we are talking about, which we had taken for the drawing of frequency polygon, these are called as class marks. Now, how to find the class mark? Class mark can be found very easily, as it is just the midpoint of two terms. So we can easily take the average. Upper limit plus lower limit by 2 should give us the class mark, right? Because when we are finding the middle value of any class interval, what we are doing, we are adding the upper limit and the lower limit and then dividing them by 2 to get their average value or the middle value. And this middle value is nothing but the class mark or the point which we are going to use to draw the frequency polygon. Now let us see an example. Here also we are given a continuous data, and you can see all the classes have the same class size, right? All the classes have class size 10. So we don't need to think too much about drawing the histogram, because all of the rectangles will have the same base. Now the corresponding frequencies have also been given. Now don't care so much about the data now. We will look at the construction of the frequency polygon, right? And from there we want to extract how to draw when we are given a certain set of data. Now you can keep in mind some of the data, like for 140 to 150 we have 5, for 150 to 160 we have 10, and so on. So let us see. So for the classes, we have found out class marks. You can see for 140 to 150 the class mark comes out to be 145, and you can find this out. How? 140 plus 150 divided by 2 gives us the class mark, right, or the midpoint. And where will we point the midpoint on the graph? We have to find the midpoint or the class mark at the point where frequency is 5, right? Where the frequency is 5, we will cut we will draw a point where the frequency is 5, and also the class mark is 145, or the midpoint of the class is 145. And we have done this in all the cases. So let us see. And this is how the frequency polygon comes out. And now you can see these are our obtained class marks. These are our obtained class marks, and we have here the corresponding frequencies. right? Here we have, you can see B is just above 4 and just below 6, so B corresponds to frequency 5, and also B corresponds to class range class mark 145, right? B corresponds to class mark 145, and we can draw them so on, right? And you can see the last point is G. The last point which we get in our table is G, which is 195. 195 we are getting as the last class mark, and we are joining it with H, or we are extending it to any point. We are extending it to some other point where we will have the next class mark. Like here, the final point, as we have every class mark at an interval of 10, you can see the class marks are spaced equally, 145, 155, 165 and so on. The class marks are spaced equally, and therefore we can guess the next class mark. After 195, if the spacing is 10, the next class mark will come out at 205, right? The next class mark has come out at 205, and the class mark which is which just occurs before 145, the class mark which occurs before 145 is 135, which is spaced at a gap of 10, right? Which is just spaced at a gap of 10. So what we have done, we have added 135 at the beginning, 205 at the end, and plotted the corresponding class marks on the graph according to the frequencies given, and had joined every point with a straight line, and therefore we obtain our frequency polygon without the help of histogram. And of course, histograms can be also drawn for such tables very easily, and if you are asked just to find the frequency polygon, I think you should not waste too much time drawing the histogram. So this is how we find the frequency polygon directly from the data by finding out the class marks of the corresponding frequencies. Now let us look at the final topic, which is measures of central tendency. So here are the types. We have mean, median and mode. These are the basic types of central tendency. And why are they called so? Because by the definition you will see that the values which we can obtain out of the given data by using these following methods, all these are tending towards the center value or towards the maximum value. Now let us find out what each of these terms mean and how can we extract useful information from the data using these measures of central tendency. So let us talk about mean first. And mean is nothing but average of the numbers. And what do you mean by average of the numbers? You take the sum of all the numbers and divide it with the number of terms present, right? This is how you take average. And of course this is how the average of your marks is calculated. The average of your marks is calculated during your exams. The mean or the average of a number of observations is the sum of the values of all the observations divided by the total number of observations, right? The average is nothing but the sum of all the values of observations divided by the number of observations. And the symbol of mean or average is X bar. If you see a symbol like this, X with a bar, you can instantly understand that it is nothing but the mean, which is just the average, and it can be written mathematically as sum of all observations divided by the total number of observations. This is the basic definition of mean. So let us find out, or let us understand this better with the help of an example. Here marks scored by two by a girl and a boy is given here. According to the question number 1 to 5, they have scored different marks, right? Out of 10, you can see out of 10 they have scored this much marks. So Mary's score varies from 10, 8, 9, 8, 7, and Harry's score varies in the given way. Now if we want to find out average marks or the mean of every child, if we want to find the average score for every child, average score for Mary separately and average score for Harry separately. Now how do we do it? It is very simple. Mary's average will be the sum of all the observations, 10 plus 8 plus 9 plus 8 plus 7, which comes out to be 42. The sum of all observations divided by the number of observations, and how many are there? There are 5 observations, right? So divided by 5, 42 by 5, then average score comes out to be 8.4. Or how to interpret the average? You can tell that if Mary had got 8.4 in all the tests, even then her entire score or the sum of the scores would have been the same, right? If Mary had scored 8.4 in all of the tests, then the sum would be 8.4 into 5, which is nothing but 42, right? So this is how we interpret an average. And for Harry's score, the sum of all the numbers is 4 plus 7 plus 10 plus 10 plus 10. So by adding all these numbers, we get the average score as 41 divided by 5. The sum of all the scores or the sum of the observations divided by the total number of observations. So we get here 8.2, right? So we have 8.4 as Mary's average score, 8.2 as Harry's average score. And now I think you have understood how to find out the average. We just take the sum of all the observations and then divide it with the number of observations present. Now here you can see we have a small number of observations with very few repetitions. Therefore we can individually add them up, and we can easily write the formula for it as sum of all observations divided by the number of observations present. But if we have a huge set of data with variable frequencies, you can see here in this data 10 varies with a frequency 1, 20 with a frequency 1, 36 with a frequency 3, 40 with a frequency 4, and so on, right? For this data, if we want to find the mean marks or the average marks, it is not going to be so easy, right? We cannot just write sum of all observations and it will be a huge thing. Actually, we also have a shorthand notation for finding out the sum of all observations. So let us do it in the hard way. We just correspond every marks to the frequency and find out their summation. We multiply every term with the number of times they appear and take the summation, right? This is the total marks which is obtained in this given table, right? This is the entire marks which is obtained in the given table. And the number of terms, you can add up all the frequencies or the number of numbers. You can add up all this number of terms here and you get 30 as the total number of terms. So to find the average or the mean, what you do, you divide the sum of the marks with the sum of frequencies, right? The total marks divided by the number of observations, which is 30. Now, as I was talking about the shorthand expression, so this is the shorthand expression, or we can call the frequencies as f, this one as f1, this one as f2, this one as f3, and so on. And the observations, we can call them as x. This one is x1, this one x2, and this one x3, and so on, right? We can name each observations and the corresponding frequencies in the given manner, and what we get is we are doing f1 x1 plus f2 x2 plus f3 x3 and so on, right? We are just multiplying f1 x1, f2 x2, f3 x3 and so on, as you can see in this given addition. And the sum, we can write it in a short way as a formula as summation of fi xi, and fi xi, in this the value of I varies from 1 to 13. The value of I varies from 1 to 13, and this is what the summation means. Summation of fi xi, where the variable here is I varies from 1 to 13, and it can be expanded in this fashion. It can be expanded in this fashion, right? Or if we are given such term summation of fi xi where I is varying, that means the summation is every term which is a multiplication of f and x, and with the suffix of I we have to take the summation of all these terms. So f1 x1 is a term which is similar to fi xi, which has I equal to 1, and f2 x2 has I equals to 2, f3 x3 has I equal to 3, and so on. And as we have a summation sign here, this is the sign called sigma or summation sign. As we have the summation sign here, we should multiply every term where I varies from 1 to 13, or every term starting from f1 x1 till f13 x13, and this is what the symbol of summation means. And to write the formula for sum of all observations, you don't need to write the entire statement sum of all observations. You can directly write this in the summation form. And to find out the total number of observations present, we will find out the sum of all the frequencies, or the sum of the number of times every number appears. So how to write this? It is nothing but sum of all fi, right? This was f1, f2, f3 and so on, and their sum will be f1 plus f2 plus f3 plus f4 and so on up till f13. So we write it as summation of fi where I varies from 1 to 13, or we are adding f1, f2, f3 and so on, and for every case I is varying as 1, 2, 3, 4 up till 13. So I think you have got the meaning of this symbol. Whenever we are given a symbol summation and something here fi xi, where I is a variable, I equals 0 to some value, suppose n, this statement means we have to add up all the terms starting from 0, means f0 x0 plus f1 x1 plus f2 x2 and so on up till fn xn, right? You should be careful of the starting value and the ending value. Now here we have taken all the terms starting from 1 to 13, so we are adding all the terms f1 x1 up to f13 x13. And here also we are adding all the f's, all the frequencies starting from f1 till f13. You should be careful of the starting and the final value and also the term given in the summation symbol. So this is how you can find out the mean, and you can write the formula of the mean in shorthand in the same fashion: Fixi, where I varies from 1 to n, the summation, and divided by the summation of all the frequencies, where I varies from 1 to n once again, right? Because here you have n observations, and of course for n observations you must have n frequencies. So this is a shorthand representation of mean, or finding the average. Okay, so now let us come to the next topic, which is median. Median is that value of the given number of observations which divide it exactly into two parts, or if a given set of data is there, then if we find out the central value, and the central value will of course divide the data into two equal parts, and that central value is called as the median. And from the term only it seems median must be somewhere in the middle, right? And the term exactly tells us that the number which we are finding should be exactly in the middle. But be careful, when we are finding the observation which occurs in the middle, we must first arrange the data in an ascending order or a descending order. If we are arranging in a certain order, then only we can find out the central value or the median. For example, if we are considering the heights in centimeter of 9 students of a class, which are given here, the heights of 9 students of a class are listed here, as you can see, and the values are not arranged, right? So if we are asked to find the median of this given set of data, we first arrange the entire data in ascending order, or if you like, you can arrange them in descending order. So here we have arranged the data in ascending order, and here the number of terms given is 9, right? So which value do you think is the central value, or which value divides the entire group into two equal parts? Of course, when we are looking at the central value, we must look at that value which is at equal spacings from either side. From the back side, the gaps are equal, and from the right side also, from the forward also, the gaps are equal. So here, if we take the reading 149, you can see there are 4 numbers ahead of it and 4 numbers behind it, right? So this value 149 must divide the entire data into two equal parts of 4 number each. So 149 is nothing but the median. The middle term, or the median, is therefore the 5th term, which is 149. And have you seen one thing? When we are given 9 terms, we are actually looking at the 5th term, which divides the entire data into two equal parts, and not any other term. Even if we are given a different set of data with 9 terms, with 9 different terms, we will actually look for the middle term, which is the 5th term once again, because for the middle term we will have 4 numbers behind it and 4 numbers ahead of it. Now how can we find the middle terms directly if we are given 9 expressions? You can see the 5th term can be written as 9 plus 1 by 2, right? The 5th term, or the middle term, can be found out using the formula 9 plus 1 by 2th term. So this is how we find the middle term. And suppose we are given a huge set of data with more than 10 number of terms, or we can say if we are given a data of n terms, there are n terms. So when the number of observations, which is n, is odd, like here we had the number of observations were 9. If the number of observations are odd, there will always be a central number which divides the entire group into two equal parts. And which is the term? It is n plus 1 by 2th term, right? For 9 observations we had 9 plus 1 by 2, which was 10 by 2 or 5. We had looked at the 5th term, right? So if we have n observations and the value of n is odd, what we do, we add 1 with it and divide the entire sum with 2, and therefore we get the term, we get the number of the term which will be the central value. And by checking the value of that number, we can directly write the value of the term, right? We can directly write the value which is the median of the given set of data. Now let us look when n is even, when the number of observations are even. Now here we are given the points scored by a kabaddi team in a series of matches are as follows. So find the median of the points scored by the team. So we are given a big set of data, and if you count the number of terms, we actually have 16 terms. We have 16 terms, and what we do, our first step will be arranging all the data in ascending order or descending order, and we are following ascending order because it is easier to arrange. So we arrange the data in ascending order, and if you count the number of terms, the number of terms comes out to be 16, which is even. The number of terms is even. So if there is even number of terms and you are trying to find the central value, you will actually get there are two terms which are equally spaced from behind as well as from ahead. And here the two terms are 10 and 14. And why is it so? You can see if we take these two terms as the central terms, there are 1, 2, 3, 4, 5, 6, 7 terms which are ahead of the number. There are 7 terms ahead of these two numbers, and also 1, 2, 3, 4, 5, 6, 7 terms behind the number. So these two terms as a group has divided the entire group into two equal parts. And remember, we should always look for the minimum number of terms which are making the entire group get divided into two equal parts. And here we get two numbers which as a whole divides the group into two equal parts. So we can't have two medians, right? We can't have two middle values. Middle value can be only one. So how to find the middle value of these given terms? So what we do, we just find the middle terms, which is here the 8th and the 9th term, and just find the average. We just find the average of the two middle terms, and here the average comes out to be 12, and 12 is the median of the data. And suppose if you are given 17 terms, and here at this place at the center you put the value 12, even then the median would be 12, right? The median will be 12 because you will have 8 numbers behind it as well as 8 numbers ahead of it. So for finding the median of even number of terms, as we have even number of terms, they can be just divided into two equal parts. Therefore we need two numbers as a group to make the group split into two equal parts, and to find the median we take the average of the two central values. So here you can see we look at the 8th and 9th term when we are given 16 terms. And how do we find which term to look at when we are finding the median? You can see to find the 8th term we have just divided the number of terms by 2, and to find the 9th term we had just added 1 to the earlier result, right? So to find the term to look at to find the median, we have to do is divide the number of observations with 2 to get the first term, and then divide the number of observations by 2 add it to 1 to get the next term. So we get the 8th term and the 9th term. We look at the values and take their average, and that will give us the median. So when we try to write it as a formula, when the number of observations is n or more than a certain value and the number of observations is even, we have two central values, and the median is nothing but the mean of the two central values. And how to get the central values? You just divide the number of observations by 2 to get the first observation, and then you add 1 to the earlier result to get the next observation. And what you get from these divisions n by 2 and n by 2 plus 1 is the placing of the terms, or where the terms are, right? Either it is the 8th term or the 9th term. And be careful, do not take average of these two numbers. Do not take average of these two numbers. These only gives us the positions of the numbers, and the actual numbers in the data should be taken for the average. Like here, we had found the 8th term and the 9th term must be at the center, but we had found the median by actually looking at the 8th term and the 9th term, right? We had not taken the average of 8 and 9. So be careful not to take the average of these two numbers, and always find the data corresponding to the terms you have got and take the average of those two numbers which are given in the data. And this also holds for observations where n is odd, right? You are finding just the location of the number in the given data, and you are actually specifying that data as the median. Like earlier we had found that the 5th term was the median, right? The 5th term was the median, and 5 was not a median, right? 5 was not a median. 5 only specified the location of the number, and what was the number? It was 149. So 149 was median of the number and not 5. 5 only gave us the location of the term. So these numbers only tell us the location of the terms when arranged in ascending order, and you must find the terms from the given data and then take the average. So this is how we find the median when the number of observations is even and the number of observations is odd. And remember, median is just the central value, so it is very easy to find out. So next we come at mode. Now the mode is the value of the observation which occurs most frequently, that is an observation with the maximum frequency. Like if we have a set of data where some value occurs one time, some value occurs twice, some value occurs 4 times, and so on. So our mode will be the number of the value which occurs more number of times, or the value which has occurred 4 times, right? Let us look at an example to get a better idea of it. So find the mode of the following marks obtained by 20 students. So here we are given marks in a random arrangement. So our first step always will be to arrange them in ascending order so that we can look at the data in a good manner. We can look at the data and can get the result directly from it. So here you see that 2 occurs once, 3 occurs twice, 4 occurs thrice, and by checking the number of occurring terms, you actually end up that 9 occurs most frequently. No number here occurs as frequently as 9. 9 occurs 4 times, and all the other numbers occur less than 4 times, right? So here 9 occurs most frequently, so mode of the given data is 9. So this is how we find the mode. And of course, once again, if you have the maximum observation, if you have the observation which has the maximum frequency and the number of such observations comes out to be 2, what you do to find the mode? You once again take the average of the two numbers. So you see, when we have more than one central value or more than one mode, what you do? You find the average of these two numbers to find the actual mode. So let us apply all these concepts to one question to find out the mean, median and mode of Mary's score, right? So that we can recapitulate what we have learned so far. So first, our first step always will be to arrange the data in ascending order so that we can interpret the data very fast. So you can see, when we add up all the numbers and divide it with the sum and divide it with the number of observations, like when we add 10 plus 8 plus 9 plus 8 plus 7, we had obtained 42, right? And here the number of terms is 5. So therefore we get the mean as 8.4. So this is the mean. Now what is the median? When we have arranged the data in ascending order, the central value, this is the value which occurs at the center or which divides the data into two equal parts. This is the median, or median is 8. And what is the mode? Mode is that observation which occurs the maximum number of times, which has more frequency. And here you can see 8 occurs more than once, or it has the maximum number of occurrence. It occurs the maximum number of times. So our mode is 8, right? Our mode is 8. Now why are we arranging the data in ascending order? You can see, if suppose we have not arranged the data in ascending order, our median would have been 9, and our mode also, and our mode would have been 8, because mode is just the number of times of occurring. So mean and mode you can do without arranging the data, but arranging the data will be quite helpful. But for median, arranging the data is mandatory. Why? Because if the data is given in a random order, you will end up with the wrong result. The median here, if the data is not arranged, you get as 9, but actually the median should have been 8, right? The middle value when entire data is arranged in ascending order or descending order. So this is how we find the mean, median, mode of any given data. And you can see the data need not be continuous or given in certain specific intervals. We can find out the mean, median, mode of any such data. So in this class we had completed graphical representation of data with the frequency polygon, and now recently we have talked about measures of central tendency, right? We have talked about measures of central tendency, which are mean, median and mode. So for better understanding of these topics, you can always log into Webcoach, and you should also follow your school textbooks. Your NCERT books are a must, and for further practice, always you can go for different books like the TMH group. So thank you, and